Hi everyone. So in the last video that I made was about Bowen's reaction series, and here is Bowen's reaction series. And just to kind of recap everything, basically what this chart is all about is about how you could take one kind of a magma and make many different kinds of rocks out of it. And basically it comes down to, how much silica does a magma have or a lava have. If it's got a little silica, then you would make types of rocks that are more basaltic. The crystallizing of material would stop basically at the basalt or gabbro stage. Okay. If your magma has a lot of silica, you could go on and make granite types of rocks. Granite that might have a lot of quartz in it or a lot of muscovite mica. Okay, so what does this mean for making rocks in the real world? All right, so here's a picture of a magma chamber deep under the earth, and this magma chamber is cooling. Now, this magma chamber is going to cool, presumably around the outside. I think that makes sense. And the stuff that would be forming first around the outside would be the basaltic rock. These would be like rocks that were like, let's say, olivine or pyroxene, or rocks that are high in calcium plagioclase, for instance. As this magma continues to cool, we would form rocks that are lower on Bowen's reaction series. Maybe rocks that are higher in sodium plagioclase, or rocks that are higher in amphibole. Okay, so here's a layer of different rocks that are forming within that magma chamber. If this magma chamber has enough silica in it, and it continues to cool, what you would form in the center there might be more granitic kinds of rocks, and rocks that have lots of silica in them, maybe quartz, mica, and potassium feldspar. So what we're going to do now is use Bowen's reaction series to actually classify igneous rocks. And I've got this picture here that shows the classification of igneous rocks, and it is based on Bowen's reaction series. If you look at the right side of this diagram here, basically we can really trace out Bowen's reaction series by just looking at this identification chart. The first things that would crystallize out of a magma, according to Bowen's reaction series, is olivine. And if it cools some more, it goes down to pyroxene. And you form calcium-based plagioclases. As that crystallization continues, you form more sodium-rich plagioclases. You also form amphibole and biotite. Cool it some more, and you begin crystallizing out quartz. Cool it some more, and you are crystallizing out feldspars, and so on. So we can look at this classification chart and see on the far right side we've got the mafic types of rocks, which are the basaltic rocks. On the left side, we have the more felsic rocks, in other words, the granitic kinds of rocks. If we look at the top of this classification chart, we can see where this is where basalt and gabbro materials would be. This is where granite and rhyolite materials would be. And notice here, granite and rhyolite. Granite and rhyolite are practically the same rocks. The only difference has to do with how coarse or how fine the grain size. Okay? So let's say you're a geologist in the real world and you come across a rock And let's say this rock is really high in calcium and iron and magnesium, okay? And this rock, by the way, has got really a fine texture. All right, high in iron and magnesium and calcium, but low in sodium and potassium content. Go to our classification chart here, and we see that, in fact, we've got a basalt, okay? If that rock had really coarse grains in it, well, then it would be known as a gabbro instead of basalt, okay? What if you find another rock and you see that this rock has a lot of potassium feldspar in it, and it has a lot of quartz, and it's got some muscovite mica in it, okay? And that rock is got really coarse grains. Well, what you've got here is a granite, okay? So using the content of these rocks, we can identify them using this identification chart. Here's a slightly simpler identification chart. Basically, it says the same thing, but I chose to start with the more elaborate one. We're going to go on. All right, here's a slightly more complex identification table, but really nothing more than what I've already showed you. It's just got a little bit more detail. Let me just show you what I mean by that. You can do a lot more actually with this table than you could with the other two, but I wanted to work up to this one. Here, let's give this one a try. Let's say that you found a rock that had a whole lot of olivine in it, and a whole lot of pyroxene in it, and maybe just a little bit of calcium plagioclase feldspar in it, okay? And you found that this rock had a lot of gas bubbles in it, okay? In other words, it's vesicular, okay? If you found that rock, you might call that a rock scoria or vesicular basalt, okay? So you can identify that rock by knowing these traits. Let's try a different one. Let's say you found a rock and it had a little bit of amphibole in it and a little bit of, let's say, plagioclase feldspar in it, a whole lot of quartz, and a whole lot of potassium feldspar, okay? And you looked at this rock and it had really large crystals. It was definitely an intrusive rock because of the large crystals. You could call that a granite, okay? If you took the exact same rock and it had really tiny crystals, you couldn't even see the crystals, that would be called rhyolite. If in fact you were looking at this rock and it had absolutely no crystals and it really was glassy, you would have obsidian. And well, for instance, you saw obsidian in the lab, this black glass that we had in the lab. All right, last thing. So you're going to see a worksheet, this actual worksheet, in the student resource folder or as part of our assignments. I'll have this posted in assignments. I would like to see if you can do this worksheet. Let me just maybe walk you through sample A, for instance. So doing what I said earlier, all you would do here is you look at the composition of the rock that you have. In fact, I'm looking at this rock and it's mostly potassium feldspar and quartz. So you look at the igneous rock identification chart, go to the part of the chart where it's really high in those minerals, go to see where, in fact, the coarse grain is fine and the color is light and the density is low. And I think you would agree with me that sample A must be rhyolite if you look at that identification chart. I'd like to see if you can do this, all right? I'd like you to try it. I think when you're working on this worksheet, you're going to want to have that identification chart, let's say, next to you. So maybe you can I'll have it in the student resource folder, and you can print it off and you can work from there. Give it a try. Let me know what you think. You can email me with any questions that you have. Thanks.